Hi, I'm Morgan Dye, and I'm doing my presentation today on spectroscopy. And identifying a pure substance is complicated. It requires the knowledge of formula and the structure of the molecule. For this experiment, we're introducing a couple of different methods or techniques that are used to identify simple molecules. Both methods measure the amount of the electromagnetic radiation used in the sample, but they both use them differently. Okay. The absorption in the infrared region leads to an increase in energy of a molecular vibration and doesn't affect the electrons. In the graph, it shows different dips. Each of these dips is the absorption, and using the absorption level, you can determine what functional groups are present in that molecule. And the reason for the different dips is because each functional group absorbs a different frequency in the infrared region. Okay. And then this here is just a table showing the different absorption rate, the range of the absorptions for each different functional group. And for NMR, the absorption is in the radio frequency region, and it leads to the excitation of the hydrogen nucleus, or the protons. The MRL tells you two major pieces of information. It tells you how many different kinds of hydrogen atoms are present, and it also tells you the relative numbers of each type of hydrogen atom. And this results in seeing the number of peaks in the molecule in the graph, which is the number of different hydrogen bonds. And then I have an example here. There's H3C, CH2, and OH, and it has three different hydrogen bonds, as you can see. And this is the result. It results in three different peaks on the NMR spectrum. And the ratio for this specific example would be 3 to 2 to 1. So I had unknown 33A, and with this chart I was able to tell that this was an OH bond because the absorption was between 3100 and 3500. And then also over here there's the CH bonds because the absorption is between 310 and 2800. And it limited my options between the molecules that we had to either methanol, ethanol, T-butanol, or 2-propanol. And then for the NMR part of it, it showed two major peaks, this one here and this one. And the ratio of those were 1 to 3. And the only molecule of the four with the two peaks and a ratio of 1 to 3 was methanol. So therefore, unknown 33A I found to be methanol. In summary and conclusion, the infrared spectrum doesn't give you enough information just on its own to determine the molecule. It gives you enough to narrow down your choices. And then using the NMR spectrum, it gives you the exact ratio needed to identify the correct molecule. And in conclusion, these two methods are very useful in identifying a pure substance.